Okay, so I'm going to draw how to wire this unit. Disclaimer, this does not mean that you can go out and wire in an air conditioning unit. There's a few safeties and limits that are not going to be included in this diagram that are very important to your system. This is only to teach introduction to the circuitry of an air conditioning system that uses both 240 volts and the 24 volt control. I'm going to be drawing low voltage in green and high voltage in black. So our low voltage will be starting at the back of our step-down transformer. We're going to have our wire for 24 volts going to come first from the transformer to the fuse. Then from the fuse to our safety float switch. After the safety float switch, it is going to come to our R. In this case, we have an RC and an RH, so it's going to go to both. Next, we will have a common. This common will be used multiple times. So we're going to bring this to the side, at which point we will have a wire nut to reuse it for future. It will also come and attach to the C on the thermostat. Next, we're going to use the G wire. The G wire is for your fan. G is going to leave the thermostat, come over towards the blower relay, which is depicted here, and connect to one of the two standalone pins. These standalone pins are your coil. The other side of the standalone pin will need common. So we can run to our wire nut that we already built here. Next, we're going to wire in our heat sequencer. On one side of the heat sequencer, we're going to have W1. W1 will come out of the thermostat and to the one side of the bottom of our sequencer. On the other side, you guessed it, common. Common is commonly present. Next, in our low voltage circuit, we are going to wire in our compressor contactor. The compressor contactor will come from the Y terminal. It will leave the thermostat from the Y terminal and come all the way down to the side. The side pins on your contactor are your low voltage coil. Top and bottom are high voltage. Very important that the two are not confused. So we've connected the yellow wire to the side of the contactor. On the other side is common. Common is commonly present. That completes the low voltage portion of this. To connect high voltage, it is mostly simple. High voltage is listed here, L1 and L2. The first thing that needs to happen is our transformer needs to be powered. So L1 will go to one side of the primary voltage. The other side of the primary voltage will be L2. Now our transformer is powered and can convert 240 volts down to 24. Now the rest of our major components need to be powered. For our blower motor, which is depicted here, our blower motor will get one side of direct voltage. L2 will go directly to one wire on the blower motor. The other wire will be powered by L1, but first it has to run through the breaker. I'm sorry, not the breaker, it has to be broken by the relay. So it will come from L1 into this pin in the relay, which is normally open. Then the other run on this relay, which is the normally open circuit, will come and attach to the other leg of the fan motor. Now our heat strips. One side of our heat strips will be constantly powered from L2. The other side will be powered by L1. But it has to run through the heat sequencer first. It will attach here to the heat sequencer. On the other side of the heat sequencer, we will go to the heat strips. That way, when our W calls from our thermostat, voltage can pass through and go to this heat coil. Lastly, we have our compressor. Our compressor is quite basic. We're going to have L2 to the top of one side and L1 to the top of the other. Then L1 and L2 will go into the compressor. Once again, there are some other limits in regards to the heat strips. There's some limits in regards to a couple other areas that are not listed here. Obviously, your compressor is almost always going to need a capacitor that is not listed here. Defrost operation is not listed here. That would be level 2. This is level 1, understanding this.